Each year on National Barcode Day, we celebrate one of the most impactful innovations in modern history, barcode. Since the first scan in 1974 to today, barcodes have revolutionized the way the world tracks, identifies, and exchanges data. For AIM, the Global Industry Association for Automatic Identification and Data Capture Technologies, the day is more than a celebration. It's a tribute to the foundational tools that make today's supply chains, retail operations, and healthcare systems smarter, faster, and more accurate. Barcodes are at the very core of the AIDC community. They've enabled automation, interoperability, and data integrity for more than 5 decades. And AIM has played a key role in making that possible. Through our Technical Symbology Committee, AIM has been instrumental in the development and standardization of many of the symbologies used around the world today. This includes Code 39, Code 128, and the QR code, and many others that form the backbone of automatic identification systems. Equally critical is the role of GS1, who creates application standards like GS1 Data Bar, GS1 Data Matrix, and GS1 QR code, which define how data like G10s, global trade item numbers, and other identifiers are encoded and used globally. To help us mark this day, we're pleased to share a message with insights from Steve Keddie, Senior Director for AIDC at GS1 Global Office and the Chair of the Technical Symbology Committee with AIM. Now let's go over an insightful overview of the barcode's evolution, from early linear symbologies to the rise of 2D codes like GS1 Data Matrix and QR codes, and how these innovations are enabling a new era of product transparency, digital integration, and sustainability.
So if we go back to 1974, that's when the first UPC barcode was scanned in Troy, Ohio at a Marsh store. And the reason they started scanning these UPC barcodes back then is to really start the process of automating and improving efficiency. Before that, you would have price stickers that were being put onto products. You'd have to have multiple inventories to know what's happening with your products. And so that created a significant amount of errors. By moving to the UPC barcode, they were able to not only do price lookup, but also improve their inventory control. So then came in the ITF 14 barcode. And so the ITF 14 also carried the G10. And so now you had, now you're able to track and know what's in the case by just scanning it. But it didn't take long before they realized they needed more data.
With barcoding growing rapidly, Code 128 was designed by Ted Williams, an industry innovator, collaborator, and longtime member of the AIM Technical Symbology Committee. Code 128 was designed to address issues of Code 39, which offered higher density, efficient coding, and checksum, a built-in error detection for data integrity. This became the foundation for more advanced applications, including GS1 128.
As the advanced shipping notices were coming in, through EDI, they realized that they need a little bit better control. So then the GS128 was invented. So this is a code 128 barcode, which can carry more data. And by carrying more data, you needed to now have a structure to be able to identify what's in the case, such as not only the G10, but maybe it might be the serialized shipping container number. It could be any other additional information. So a new data structure was invented called the GS1 element string syntax. And this allowed those barcodes carrying the GS128 barcode to be parsed to know exactly what's in that. For example, it might have an SCCC, the G10, and the number of times that product, that G10, is inside that case. So as time marched on, in 1999, another new barcode came into play, and that was the RSS. And so this barcode allowed you to have additional data in it. But again, it needed to have a new structure. So what happened was the GS1 element string syntax came together with the RSS and became the GS1 data bar.
So this allowed POS systems to scan products and recognize the fact that the barcodes themselves not only had the G10, but also could look up lot information. Now, healthcare comes into the market, and healthcare wanted additional information. But the issue was the size of Code 128 barcodes and the data bar expanded stamp. They were both too big for most of their products. With that, a solution is what helped jumpstart the 2D revolutions we are still seeing today.
So data matrix in the form of GS1 data matrix was chosen by healthcare to start marking not only pharmaceuticals, but also instruments. Now this GS1 data matrix leveraged the GS1 element string syntax, allowing a continuation of the learnings and information that had been built up from use of that syntax. Now the GS1 data matrix not only got put onto the pharmaceuticals and devices, but it also got used to indicate rooms, indicate beds, indicate all kinds of instruments. And that was great ability now to have traceability information that really helped out. So now virtually all pharmaceutical products now come with the GTIN, a lot, a serial number, and an expiry date. So those four application identifiers are on in virtually every GS1 data matrix it's on healthcare products. So time marched on, and now the fact that the GS1 data matrix was being very successful in healthcare, back within retail, a new requirement came into place, and so GS1 data matrix started to be used for at point of sale for fresh products. In addition to that, you had a new syntax came into prevalence, and this is called GS1 digital link syntax. And the reason GS1 digital link syntax came into prevalence is that today people were now starting to look at ways to connect products to the internet. And the digital link syntax allowed QR codes, for example, to connect to information online through a structured URI. Then what happened was we started to see a significant amount more requirements coming in from regulators and through the brands to connect products to more information. And the reason that they wanted to connect to more information is because the consumers were demanding it. So the invention of the digital link and adding it into the QR code really made a significant difference in allowing us to now connect to this more enriched data. Now what's happening is as we move towards 2027, the industry has set an ambition to be able to use QR codes and data matrices at point of sale, and also now moving into the supply chain to connect products to that enriched information. And because of it, regulators are also using that same QR code to help with recycling and reusing and a lot of other circular economy aspects. Going into the future, we're not sure where we'll end up, but at this point, it looks like a very bright future for barcodes as they continue to empower industry.
As we celebrate the legacy and continued evolution of barcodes, it's important to recognize the collaborative work that make these innovations possible. AIM's Technical Symbology Committee plays a vital role in developing, maintaining, and promoting the various symbologies, like the QR code, that power global commerce and data exchange today. If you're passionate about shaping the future of automatic identification, we invite you to join the TSC and contribute your knowledge to the next generation of barcode standards and solutions. To get involved and learn more, visit aimglobal.org or reach out to us directly. We'd love to have you at the table.